All right, so this is our third day on exponents, and today we're going to talk about two new rules, and this is for multiplication and division. Now remember, multiplication, when you see the word product, that means it's multiplication. If you see the word quotient, it's a division. So anyway, here's the laws of exponents. Remember at the beginning we talked about x to the fourth power. So x is your base, so we're going to put x in here for the base, and the exponent is the 4. So there's my exponent of 4. That means x to the fourth means I take my x and multiply it times itself 4 times. So this is x times x times x times x. All right, so that's the expanded version. X to the fourth looks like this when you expand it out. All right, so here we go, multiplication. If I've got b times b times b, how many b's are being multiplied together? Yes, you're correct. This is b to the third power. Now remember, these all have little exponents, even though you don't see them. There's a 1 there, and a 1 there, and a 1 there. Now notice if you add up 1 plus 1 plus 1, what do you get? You get 3, b to the third power. Now if I want to multiply x to the third times x to the fourth, right, I can expand this out. I've got 3 little x's being multiplied together for x to the third times another parentheses with x to the 4 over here. So this is going to be x times x times x times x. So if I expand x to the 3 times x to the 4th, this is what it looks like. All these x's are being multiplied together. So how do you write that in shorthand form? Count them. 1, 2, 3, 4, 5, 6, 7. All together there's 7 x's being multiplied together. That's x to the 7th. Do you notice that over here, if the bases were the same, how many x's are being multiplied all together? 3 plus 4 means there are 7 x's being multiplied together, and isn't that my answer, x to the 7th? Yes, it is. I have a single w times w to the 6th. So remember, this has a little 1 sitting up here as its exponent, right? So I have a single w times 6w. So I'm going to put 6 w's in here. 1, 2, 3, 4, 5. I think I can get one more in here. 6, right? 1, 2, 3, 4, 5, 6. So how many w's are being multiplied all together? 1 plus 6 more means I have 7 altogether. So this is w to the 7th. So you can expand them out and count them up, or you can just say, oh, there's 1, and I'm multiplying 6 more, so how many altogether? 1 plus 6 is 7. 2x to the 5th times, because there's nothing between the parentheses, 6x to the 5th. So these two monomials, they're just single terms, are being multiplied together. Remember, the order doesn't matter, so I can pull the 2 and the 6 out in front because they're the coefficients. The numbers in front of the variables are the coefficients. This is still just plain old 2 times 6. So I pulled the 2 times 6 out in front. I've got 5 x's being multiplied together and another 5 x's. So here's my 1, 2, 3, 4, 5 with dots between them because they're all being multiplied, right? And here's another x to the 5th. 1, 2, 3, 4, 5 with dots between them, right? All right. So this is the expanded version of this. 2 times 6, and I've got x to the 5th times x to the 5th. So 2 times 6 is 12. Plain old math, just multiplying them together. How many x's are being multiplied together all together? If you count them, there's 10 of those. So this is x to the 10th. So back to the original problem. 2 times 6, the big coefficients, is 12. X to the 5th is 5 x's. Here's 5 more x's being multiplied together. All together, they're x to the 10th. So that's how we got our 12x to the 10th. Now, here's another monomial in here being multiplied because there's nothing between the parentheses. So I have a negative 5 as the coefficient and 4 is the coefficient. So I pulled them out front. Negative 5 times 4, you just do that plain old math. Let's go ahead and write that answer down. Negative 5 times 4 is a negative 20. So there's the number in front of the answer. That's the coefficient in front of it. B to the 3 and then b squared. So I've got b times b times b. So there's my b to the 3 times b squared in this one. So I've got b times b. And then a squared, so here's my a squared, a times a. So this is the expanded version of it. How many b's altogether? B to the 5th. How many a's altogether? A squared. So if we go back to the original problem, negative 5 times 4 gave you the negative 20. b3 times b squared means altogether I have 5 b's being multiplied together, so there's b to the 5th. And there are not any a's in this one, but there are a squared, so I'm still multiplying times a squared on the end. So, multiplication law of exponents says, multiply the coefficients. Those are the big numbers out front. That's what we call them as coefficients. You're just plain old multiplying like we normally do. Those are just plain old numbers being multiplied. So multiply the coefficients, then expand the variables and add them up, or shortcut is just to add the exponents that have the same base. Because remember, the b's I could add together, but I couldn't add the b's and the a's together. The b's, there were 5 of those, and there were 2 a's. So make sure you keep the bases separate. So as long as they have the same base, you can add their exponents as a shortcut to expanding them out and counting them up. All right? Now, on your reference sheet, start test date, you have these properties of exponents. Here's your product powers, what we just talked about. If you've got a with an exponent of m and a with an exponent of n, the bases are the same. They both have an a and an a. What do we do with those exponents as a shortcut? See how they added them here? You can see that plus sign. So that reminds you that when you're multiplying, because there's nothing between here, and product is multiplication, so there's nothing between them, so this is a multiplication problem, you add the exponents. All right? Now, for the division, expand again. I got x to the 7th divided by x to the 3rd. So there's 7 little x's here being multiplied together and 3 little x's here being multiplied together. Now remember, if you have the same thing on top and bottom of a fraction, they cancel out. So 1x and 1x cancels out. 1x cancels out. 1x cancels out. I can't cancel anymore because I'm out of things down here. But how many are left over? 4 x's. So how do you write that? That is x to the 4th over 1, because there's nothing on bottom anymore. Do we need to write the over 1? No, we can just go away, it's x to the 4th. All right, so back to this. So there were 7 x's on top, 3 x's on bottom. 3 of these cancel out 3 of those. How many are left alive or left on top? You still have 4 left on top. That's how we got x to the 4th on top. X squared over x to the 4th, so there's 2 x's on top, 4 x's on bottom. We can cancel out 1 for 1, 1 on top, 1 on bottom. How many are left over? 2. And are they on top or are they on bottom? So they stay on bottom. This is x squared, right? So 1 over x squared is the answer to x squared divided by x to the 4th. Notice you had 2 on top, 4 on bottom, so 2 of these cancel 2 of those, and you're left with 2 on bottom. Now, what do you do with the big numbers out front? These are just plain old numbers. Just put in the calculator, 6 over 2 in the calculator. 6 divided by 2 is 3. So in the final answer, you have a 3 on top. But they're just showing you that the 6 over 2 makes its own fraction. You just put that in the calculator as normal. Now, b's, I have a single b on top and 3 b's on bottom. So they kind of did it here as a more expanded version. So 6 over 2 becomes a 3. b over b3. 1 on top, 1 on bottom cancel out. How many are left over? 2, and they are on bottom. B squared. So back to the original one, 6 divided by 2 was your 3. 1b on top, 3 b's on bottom. One of these cancels one of those, so you're left with 2 on bottom, and there's my b squared on bottom. So 12x to the 5th b divided by 3x squared b3. Again, the big numbers out front of your coefficients, plain old math, 12 divided by 3. So we put it separate, 12 divided by 3. And when you do that, you get a 4 in the calculator, and that 4 is on top. Right, 4 over 1. You don't have to put the 1 on bottom, but it's there. X to the 5th means I have 5 x's on top and 1 b, 2 x's and 3 b's on bottom. So here it is again over here, so we can cancel out. A single x on top, single x on bottom, single on bottom, single on top. So 2 canceled out. How many are left over? 3 x's on top. Now I have a b on top and a single b on bottom cancel out. So how many b's are left over? 2, and they are on bottom. So see how that works? 12 divided by 3 is your 4. I got 5 x's on top and 2 on bottom, so these 2 on bottom cancel out with 2 on top. How many are left over? They're 3, and they're on top because you had more on top to start with. A single b canceled out one of these b's on bottom, so you got b squared left on bottom. So you're actually subtracting the exponents and leaving the extras where the bigger number was. All right? So division law of exponents. This is your division law, and it is also over here on your quotient powers, right? So quotient is division. It shows you a division problem. The bases, a's and a's, are the same. What do you do with the exponents? You subtract them. And I just always take the biggest minus the smallest and then leave the leftovers wherever the bigger number was. So that just makes it easier for me to not have to deal with negative exponents. So divide the coefficients. That's just plain old math again. If I can write and talk at the same time. Let me write this in. There we go, coefficient. So the coefficients, the big numbers out front, you just divide them as normal. Then expand and cross off the variables or use the shortcut, which is subtract. So when you're dividing, what you wind up doing, because you're crossing off, is you're subtracting the exponents with the same base. The leftovers go on the side that had the bigger exponent. Okay, so there are your rules. Now let's go do some. And on this worksheet, I've got your rules up here so you can get used to seeing them. The product powers, where you add the exponents when it's a multiplication problem. You subtract the exponents when it's a division problem. All right, so here we go. This is a multiplication problem. So what do you do with the big numbers out front, the 4 and the 3? You just multiply those as normal. 4 times 3 is 12. I've got y squared times y to the 3. So I've got 2 little y's here and 3 little y's here. Altogether, how many y's are being multiplied together? There are 5. I add those exponents. 2 plus 3 is 5. Now, I don't have any x's here, but I still have x squared here, so I still need to have an x squared. I'm still multiplying times x squared in the answer. So 12y to the 5th x squared is the answer. Number 2, I've got mn to the 3rd. Remember, there's a 1 in front of that, and there's a little 1 is the exponent for the m. 4m4n squared times 2m3. So the big numbers, 1 times 4 times 2, they just multiply together. Well, 1 times 4 is still 4. 4 times 2 is 8. So you can put those in the calculator and just do the math. M's, I've got a single m to the 4th. So how many m's here? 4, 1 m here. Altogether, 1 plus 4, there's 5 m's, plus 3 more, that's m to the 7th. So altogether, no, that was 5, that's 8, m8, sorry. 1 plus 4 plus 3 is 8. Now the n's, I have 3 n's here and 2 n's here. So 2 plus 3 is n to the 5th. So altogether, I'm multiplying 5 n's together. So 8m to the 8th, n to the 5th. There we go. Number 3, multiplication problem. So again, when we do the exponents, we're adding the exponents if they have the same base. But the big numbers, 3 times 4 is still just plain old math. 3 times 4 is 12. Exponents, I've got x to the 3rd, and there's another x over here. So they have the same base, x's and x's. So 3 plus 1 is x to the 4th. No y's here, but I just have y3 being multiplied, so I still need to have times the y to the 3rd there. All right. Number 4, multiplication problem. Coefficients you multiply as normal. 2 times 3 is 6. Now x's, there's a single one exponent there for that x. There's a single x. So I have x here and x here. So this is what's 0 plus 1. 0 plus 1 is 1, so this is still just x to the 1st power. Y to the 3rd, y to the 3rd. So what do I do with the exponents? You add them together. Altogether, you have 6 y's being multiplied together. So that's y to the 6th. Now, another way you could have done this was said x to the 0 is a big old 1, right? It just goes away. Now it becomes like a coefficient number. So 2 times 3 is 6. 6 times 1 is still 6. Do I still have an x here? Yes, there's still an x there. So whether you added them together in the beginning with the x's, or if you changed it to a 1 and multiplied it times the coefficients, either way you still get the same answer. Okay, what's wrong with this answer? I'm just going to do the math and see what we come up with. There's a 1 in front of this one, so 4 times 1, the big numbers, is a 4. What did they do wrong? They tried to square the 4, but the 4 has its own little exponent up here for 1, so I just have 4 times 1. So 4 times 1 is 4, not the 16. M squared times m to the 3. What do you do with the exponents? You add them if the bases are the same, so that's m to the 5. What did they do? They multiplied them to get a 6, so don't multiply the exponents. You add the exponents. No m's over here, so this is still n squared, so they did that piece right. Got it? All right, what did they do wrong on this one? I got 4, and there's a 1 in front of this one, and there's a 2 there, so 4 times 1 is 4. 4 times 2 is 8, so they were correct with 8. X squared times x to the 3rd. What do you do with the exponents? You add them. That's x to the 5th. And I got 2 more x's over here, so that's x to the 7th altogether. And they came up with the 12, so they must have multiplied something in there and did something wrong. Y to the 4th times y squared. Add the exponents. The bases are the same. That's y to the 6th. There we go. And they did that wrong. They multiplied those again. 4 times 2 to get 8, so they did that wrong. So there was the correct answer on that one. Some division problems here. Now, when I'm doing division, I always check to see if there's any negative exponents first. If there are, what I do is move them and rewrite the problem with only positive exponents. It makes it easier to do that subtraction when they're all positive numbers. So these are all positive exponents. I don't need to worry about that. Now, remember there's a 1 in front of this. So the big coefficients is just 1 over 4 in your calculator. If you put that in the calculator, it tells you it's still 1/4. It is reduced as far as it will go. So in my answer, I still have 1 over 4. All right. Now, x's, I have x's on top and x's on bottom. I only want to have a single x. So this is 3 x's on top, 4 x's on bottom. So what do? We subtract the numbers. 4 minus 3 is 1, and where are the leftovers? On bottom, because there were more on bottom to start with. So I have a single x on bottom. Or you can think 3 of these canceled 3 of those, and so I have 1 left on bottom. I have y's on top and y's on bottom, but it's y to the 4th and y to the 4th, so they're the exact same numbers, so they just cancel each other out. So there are no y's left in my answer, because 4 of these canceled 4 of those, there's nothing left. All right, this one. Again, take the big, look for negative exponents, and there are none, and then do the big coefficients first. 2 over 4, if you put that in the calculator, it will tell you it is 1/2. So let the calculator reduce for you. So that is 1/2. Now, I have x's on top, but no x's on bottom. There's no other x's, so x3 stays right where it is. I've got y's on top and y's on bottom, so 2 of these cancel 2 of those, so I'm left with 1 on bottom. And there's your answer. The coefficients reduce as far as they can, only have one x piece and only have one y piece. Negative exponents? Yes. So what are we going to do with this piece? We're going to move it up to the top before we get going. So I'm going to rewrite this. 3 over x squared y3 over 3x to the third. Okay, so all I did was rewrite this. I moved the y to the top. So now it's 3x squared y squared and a y3 on top. Now it's positive exponent, and 3x to the third still on bottom. So big numbers first, coefficients in the calculator. 3 divided by 3 is 1, so they basically just cancel out. So those just went away. You can put a 1 over 1 in the answer if you want to, but you don't have to put the 1s in the front. Now, x squared over x3. X is on top, x is on bottom. So this is division, so subtract the exponents. 2 of these cancel 2 of those, so 1 is left over in the bottom. So I have 1x in the bottom. And y's, both y's are on top, so this is a multiplication problem on top. When you multiply, what do you do with the exponents? You add them. So this is y to the 5th on top. I've got 5 little y's being multiplied together on top. So y to the 5th over x is the final answer from that. We're just simplifying these down. All right, any negative exponents? No. So what you can do is do the big numbers out front. I have a 2 on top, 4 on bottom, times 3. So if I just want to write the coefficients, let me rewrite this down here. If I rewrite it with just the coefficients, 2 over 4 times 3. Put that in the calculator. There's the 2, there's the 4, there's the 3. Let the calculator reduce this for you. It's going to tell you that this is 2 over 12, and it will reduce it down to 1 over 6. So if you just put this in the calculator, it will tell you 1 over 6. So it will tell you what the final coefficient number is, which is 1 over 6. Now, for my m's, you could go ahead and multiply the m's together first on bottom and then do a division. But since I kind of noticed that this is m to the 3 on top and m to the 3 on bottom, won't 3 of those cancel 3 of those and they're just gone? Yeah. This m to the 3, that means that there's no other m, so m3 is still on bottom. So I'm going to write this on bottom, so I'm going to move this. There we go. So I wrote the m3 on bottom. And are there any other n's besides this? No. So there's nothing to do with it, but just leave it on bottom, m to the 4th. So there was my final answer, is 1 over 6 m to the 3rd, n to the 4th. We're just following the rules. So again, it's a division problem, but I've got a negative exponent. So before we get going, I'm going to move it down. And this y to the 0 just becomes a big old 1. So that's just like times 1. So this y is going to come down. So I'm going to rewrite this. So hang on a sec while I rewrite. All right. So all I did was the 1 times 2 is still 2, and I brought the y down, which is now y squared. So I've rewritten it. So now I have 4 over 2 in the calculator. So just put that in the calculator, let it reduce it, and 4 divided by 2 is 2. So in my answer, I'm going to have a 2 on top. 4 divided by 2 is 2. Now I've got x's on top and x's on bottom. I only want one x piece. So 2 of these cancel out 2 of these, so the leftovers are on bottom because there were more on bottom, so there's 1 on bottom. So shortcut was you subtracted the exponents. 3 minus 2 is 1, and you put the leftovers on bottom. It's only one y piece, so it stays where it is, y squared, and there it is on bottom, y squared. So the y squared didn't have any other y, so it stayed on bottom. So there was your final answer. 14, any negative exponents? Nope. Now, if you want to look at the coefficients, there's a 1 in front of this and 1 in front of that. Well, 1 times 3 is still 3, and 1 times 2 is still 2. So I just need to look at these pieces. So if you put 3 over 2 in the calculator, and you could do 1 times 3 on top and 1 times 2 on bottom, the calculator will tell you it is still 3 halves. So this is still 3 over 2. So there's my 3 over 2. Now I have x's on top and more x's on top and x's on bottom and y's on bottom. So what you might want to do is go ahead and multiply all the x's together and y's together on top and multiply everything together on bottom and then do one final division. So x squared times x squared, I add them, and that's x to the 4th. And then I still have a single y on top. So x to the 4, y on top. On bottom, I've got a single x times x to the 4th, so 1 plus 4 is x to the 5th on bottom. That's not a very pretty 5. There we go. So x to the 5th on bottom, and then y times a single y. Single y times a single y is y squared. So I added 1 plus 1 is 2. So now I have this. So 3 over 2 is still 3 over 2. There we go. 3 over 2 is still 3 over 2. I got 4 x's on top and 5 x's on bottom. So 4 of these cancel 4 of those. I'm left with 1 on bottom. 5 minus 4 is 1. So I've got 1 x on bottom. And then I've got a single y on top and two y's on bottom, so that 1 cancels out one of these. I'm left with 1y on bottom. So your final answer is then 3 over 2x to the 2xy. 3 over 2xy. There you go. So that is your lesson for today. Hopefully you've been checking your answers and doing some on your own and then checking. Bye, guys.